And here are all these, whatever was there before mentioned. Triangle. Here is sine formula and a cosine formula. This is what was there in the presentation also. And then if you need some other types of equations of geometry, they are all here. And there's actually quite a lot of them. So now this book might become quite useful for you already. If you need something like this you will need then in the geometry section of the maths, engineering mathematics 2 also. Yeah, and then it's the vectors. Okay. And then of course the SI system. All about the SI system is in this book. It's somewhere. For sure you checked it in the physics already. Where is it here? Strength. Maybe it was after that. Here. Unit for unit conversions. This might become useful as well. SI system. Here base units. And multiple SI units. There's many pages of SI system, basically. Here in the back of the this equation book. Okay, but now what we were supposed to do was to use the sine formula and the cosine formula for these exercises to learn to use them. So if we have something like this and you have to solve these parts. C. Obviously, you can use either the cosine or the sine formula, but for example, the sine formula would be good here. So I'm in the technical formulas, page 18, and I have found the sine formula. And it is like this. Okay, and now I would need to solve, for example, first, well, it doesn't really matter. I can solve anything that I want first. So I can write, for example, this. I know the angle here and the opposite side. Maybe I start like that. I start solving the beta angle, for example. That's the easiest if I go with this formula. So my side here would be the 234.5, and this is divided by sine 53.2. And this would be the sine beta, and I know also the opposite side here. So this was always the opposite side of the angle here. So here obviously the opposite side is the angle would be this 53.2, and the opposite side would be this 234.5. And then I know here the opposite side, that would be the 276.5, and I could calculate the angle beta here. Solve the angle beta. So here I could progress, for example, with the cross multiplication or multiplying at the same time with the sine beta. Sine beta and sine 53.2. Or then first with the sine beta, and then after that I also multiply with sine 53.2. So I get sine beta multiplied with this number and sine 53.2 multiplied with this. Now I could put that into the brackets so that I know that's only the one with the sine. Like this. And I could divide with the number. So I get only the sine beta here. So here I have the sine 53.2 and then 276.5, and under here I have the other number that I divided with. And then when I need to then solve the beta, I have to still take the sine -1. So I get the beta is the sine -1 and the whole thing there. Like that. Okay, so then this to the calculator. Yeah, here I can have the brackets so that I know that that's only in the sine. And here the other number. And I get the, oops. That was interesting. Let's do it again. Let's do it again. I'll do it again. It was the sin. Uh, so here, of course, the brackets have to be then. I get something weird, maybe. This would be a really small angle. That's because I have R there. So now I can try if I would change it. I go shift, which one was it? Setup, maybe. No, maybe it's the menu. No. Yeah, if it's the shift setup, I don't know why I didn't get it first. So then I get the angle unit, and that has to be degree now because I need it in degrees. So I pick one. Now it's in degrees. Now it says D there. So maybe I can again go back to this and then press. No, now I didn't get it really like that. Let's try again. Why is it so small? What am I doing wrong? What is wrong with this? I think I have. Do I have something in the wrong way here? Yes, that's the problem. It would be really, really small if it would be like that. It would be actually this small. These ones are the wrong way around, obviously, because I had. No. Yeah, it's here. No, it's not here either. No. Everything should be fine. Weird. Yeah, now I have the wrong sin. That's the problem now. That's that. Now I have the correct one. Now it makes sense. Now it makes sense. I forgot to put this. I didn't press the shift button here. So the shift and then I get the sin -1. I just pressed this sin and I thought that it was that one. So then I get some angle here. It was 7.8 above, maybe something like this. Well, it was five, 9, 8, something like that. Okay. And then I could calculate the beta angle because I know that all the angles are 180 in total, so no beta gamma. There was 70.8 and minus, it was the 53.2 as well. Which would be about 56 for whatever. So it would be about 56. And then was there something else that I needed to solve? The C. So then I could again use the sine formula. For the C, or then I could also use the cosine formula. Do I have to use that in the next one? I have to use that in the next one. What if I use the cosine formula for the C? So I'll get some practice of that as well. It's also marked as C. So cosine formula. So then my A and B would be those sides that I know. So it went so that the cosine formula, that the C squared here is the A squared plus B squared minus 2AB and cosine of the angle between them. So maybe that makes sense. I'll do it that way. My C squared is the A, which would be the squared, plus my B would be the other side. Minus 2 times the cosine of the gamma that I now know is about 56. And then I want only the C. So then I still have to take the square root of the whole thingy. So the C is the square root of the whole thingy. Or then I can take it later from the answer, yeah. If my calculator is up for it. Okay, so now I can do it. I still have the answer there. That was my gamma angle. So I can write uh, 0.5. Forgot the 0.5 from there. 0.5. 234.5 plus 276.5 minus 2 times 234.5 times 276.5 times cosine of the answer. Hopefully like this. Yes. So then I get it. And this was millimeters. And it looks like these are with this kind of accuracy of 1 decimal of, so I can write this like that as well. Why is it so difficult today? 0.9 millimeters. And now I have everything solved that I wanted to solve in this. So I managed to use both sine formula and cosine formula that I found from the technical formulas. And then I can keep calculating these things. Here it looks like if I want to solve, for example, this x, it would be easy with the cosine formula. And then I can also solve this, for example, this a with the sine formula after that, and then this also with the sine formula after that. You can practice this, and I can also calculate those there. Then it starts, so then we basically have been practicing these. We can find them now after these exercises. We can find them now from the formula book, and then we can continue to solve something where we can check which formula we need, basically. Or if we need to need maybe something else, but that sine or cosine form. So continue on doing the exercises that you feel that you need to practice on, and then ask if something's unclear. 15 to be kilometers. Let's put kilometers there. Mhm. So now it looks like I get the answer in our degree. Can take it as rounded already. That was the alpha, and then the beta. It's easy again when I know all those other angles. Well, angle alpha is obviously the 180 minus 51, yeah. Well, then the B, if I know that there is a straight right angle and the whole circle is 360, then my angle alpha is, of course, 360 minus 90. This is 270. And then see if it's the, well, seems to be the same, on the same place. So it has to be also 37. Mm-hmm. So there is a tree. Somebody walks, and there is some shadow. Of it. Hmm. Does this make sense? This, well, anyhow, this has to be 3.35. And it has to be the point A. To the base of the tree. From point A. So somebody has to be standing here. This is really, it doesn't sound really, somebody is standing here and has some kind of a height. And it's 168 centimeters, which is 1.86 meters. Whatever. And then can I draw this? Maybe she has to be a bit shorter. Okay. Like this. So I would know some measures here. But then the base of the tree. So then this has to be the 9.8. So obviously this goes with the right angle triangle. Here's a right angle triangle like here as well. For sure it can go with something else as well. One can solve an angle and then it's the same angle for both. That would be then the angle. Hmm. So then this whole is, the whole thing is mark it like this. First have to multiply. Yeah, I have to multiply. That's all. And then I get the values. So I multiply to 13.15 with this. Quite simple. It's not maybe so clear, this. It doesn't make any sense, this. Well, this is what anyhow it meant. This kind of a figure. It can be solved other way as well, but maybe this is the way that we trained. This looks exactly the same, the 5a. It's the same exercise. So maybe I don't calculate it now. So maybe then I'll calculate the b. So here we have, maybe I have to draw up something and something. This is 7.2. And this is in total 3.2 plus 4.8. And it's a right angle triangle. So if we solve this, for example, we can mark it with comma, then we get this, then we have this this triangle, and we can solve with cosine formula, for example. Oblique triangle. Yeah, that's what it was called. I had to check. We can solve the x with the cosine formula then, because this was the x. So then this is, was it 3.4.8? So then it would be 8. So cosine gamma would be 7.2 divided by 8. And gamma would be cosine 7.2 divided by 8. Which would be 25.842. And then the x would be with cosine formula. This was the 4.8. So 4.8 to the power of 2 plus 7.2 to the power of 2 minus 2 times 4.8 times 7.2 times cosine from to 5.8. This. Like that. This is not in the power of 2. I think I got a negative root. Okay, now it went. That's meters, yeah. So then it would be 3.6 meters. Okay. So I think this was our a bit dull lesson for this time because it looks like it's already 11:35 and next time we can continue there at the school again. So see you later this week.